At first, Albert Einstein dismissed the idea as complete nonsense. However, about a century ago, as researchers gathered increasing evidence that the universe is not a static, unchanging entity, even the father of relativity had to acknowledge his mistake. To this day, the discovery of cosmic expansion remains closely associated with the name Edwin Hubble. It's no surprise, as the young American astronomer was the first to identify the true nature of a mysteriously flickering distant star and demonstrate that the Milky Way is not the sole galaxy in the universe. Hubble's groundbreaking discoveries ultimately laid the foundation for the Big Bang theory. However, this is just one aspect of the astronomical story, as the reality also reveals that the universe continues to expand. Although astronomy is often clouded by enormous uncertainties and presents experts with seemingly unsolvable problems, certain fundamental principles remain undisputed. According to widely accepted theory, the universe came into existence approximately 13.8 billion years ago with the well-known Big Bang and has been expanding ever since. However, if we rewind time by about a century, specifically to the year 1917, we find that even the greatest minds in physics once held a very different perspective. Notably, Albert Einstein initially believed that the cosmos was neither expanding nor contracting but instead existed as a completely static structure. Einstein found the idea of an absolute beginning to be inconceivable. To accommodate this, he modified his field equations by introducing a cosmological constant after realizing that his original work implied the universe could not remain static indefinitely. Although some scientists incorporated this constant into their calculations, the astronomical revolution was already well underway. On the opposite side of the world, aspiring astronomer Vesto Slipher of Lowell University in Flagstaff, Arizona, dedicated himself to studying the motions of the enigmatic spiral nebulae. In doing so, he entertained a hypothesis that sharply differed from the views of his peers. Could it be that these mysterious formations were not structures beyond the Milky Way? This assumption, though cautiously stated, seemed unusual at the time. This becomes evident when we consider that the Milky Way was then believed to be the only galaxy in the universe. However, as we now understand, the observations made by Slipher and his colleagues would fundamentally transform our cosmological perspective, quite literally. Even in the early 20th century, astronomers understood that an object's light spectrum reveals both its motion relative to us and its speed. For instance, when a star moves toward us, its electromagnetic waves become slightly compressed, shifting its light spectrum toward the shorter wavelength blue end. Conversely, when a star moves away, its radiation stretches, causing a shift toward the red end of the spectrum. The challenge, however, lies in determining the star's original light spectrum to measure the degree of red or blue shift accurately. Slipher tackled this problem using insights from Joseph von Fraunhofer, Robert Bunsen, and Gustav Kirchhoff. Light spectra contain not only spectral lines but also dark absorption lines, which appear when specific elements absorb portions of the radiation. Since the wavelengths of these lines were already known, Slipher realized they held the key to identifying the spectral shifts of celestial objects. With this in mind, the astronomer conducted initial investigations using a spectrograph mounted on a telescope, closely examining the Andromeda Nebula, M31. Unbeknownst to him, he had just caught a glimpse of our neighboring galaxy. How Edwin Hubble transformed astronomy. Despite these challenges, Slipher managed to uncover some fundamental characteristics of spiral nebulae. For instance, it became clear that they appear to rotate on their own axis and that M31 is approaching us at a speed of 300 km per second. However, the Andromeda Nebula also deviated from the pattern Slipher had observed. While other nebulae seemed to be receding from the solar system, M31 was moving toward it. At the time, Slipher had no way of knowing just how pivotal this discovery would be for the future of astronomy. The field of astronomy underwent a major transformation with the arrival of Edwin Hubble. Since 1919, he had been dedicated to uncovering the true nature of the enigmatic nebulae. At the time, most experts believed these structures were part of the Milky Way, understandably so, given that it was widely considered the only galaxy in the universe. Determined to measure their distances, Hubble conducted his research at the Mount Wilson Observatory in California. Following the best traditions of scientific investigation, he focused on the Andromeda Nebula, M31. However, even in moments of astronomical breakthroughs, luck can play a role. In October 1923, while comparing a series of photographs of Andromeda, Hubble was astonished to find a distinct point of light that periodically changed in brightness. These flickering light sources, known as Cepheid variables, remain crucial reference points for measuring cosmic distances. Even in Hubble's era, scientists already understood that the brighter a Cepheid variable, the slower its brightness fluctuates. The periodic pulsation of these stars reveals their distance from us, regardless of their actual luminosity. When Hubble observed a flickering star in M31, this principle led to a groundbreaking discovery. His calculations placed the star approximately 900,000 light-years away. However, given that the Milky Way spans only about 100,000 light-years, this distance made it impossible for the star to be within our galaxy. This realization led Hubble to a revolutionary conclusion: the celestial body must lie beyond the Milky Way. The universe was being rediscovered, yet this was only the beginning. Through further observations, Hubble found that spiral nebulae had long been misclassified. Much like the daughters of one siblings, they were not mere extensions of something larger but distinct entities, each a galaxy of its own. These were not just ordinary nebulae or gas clouds but independent galaxies, a fact that must be recognized. Edwin Hubble's discoveries drastically expanded the known cosmos in an instant, pushing the universe's boundaries into uncharted territory almost overnight. Soon after, Hubble realized that it wasn't just the cosmic limits that had shifted. During the subsequent period, he began measuring the redshifts of the so-called island universes and categorizing them based on distance, size, shape, and brightness. In doing so, he observed a striking pattern: the farther a galaxy is from us, the greater its redshift. In other words, the more distant a star system is, the faster it is receding from us. It soon became evident that the relationship between redshift and distance could be expressed by a constant, which Hubble estimated to be approximately 500 kilometers per second per megaparsec. Although we now understand that the astronomer's estimate was significantly overstated, his discovery marked a groundbreaking shift in cosmology. For the first time, a researcher had identified that the universe is expanding. However, this radical change in perspective was not immediately accepted by the entire scientific community. Despite the fact that Belgian priest and physicist Georges Lemaitre had already demonstrated that an expanding universe aligns with the general theory of relativity, Einstein initially resisted the idea, favoring a static universe that had always existed. In 1931, following a meeting with Edwin Hubble and British astrophysicist Arthur Eddington, Einstein reluctantly conceded that the universe, previously thought to be static for eternity, could have started expanding at some point. However, when it came to the cosmological constant, he completely reversed his stance. He removed it from his equations and allegedly called it the greatest blunder of his career. It would take more than 50 years before scientists realized just how essential this constant actually was. Despite this so-called blunder, the path to the Big Bang theory was becoming clearer. One thing that became evident much sooner, however, was Einstein's lack of enthusiasm for Georges Lemaitre. Lemaitre had proposed the idea of an expanding universe 2 years before Edwin Hubble's discoveries, yet Einstein reportedly dismissed his ideas as, and I quote, completely abominable from a physical point of view. However, Lemaitre was undeterred by Einstein's harsh criticism. He saw in Hubble's observations the missing piece of his theory: if the universe was expanding, then logically, it must have once been much smaller, possibly even compressed into a single tiny point. But the implications went even further. By taking the reciprocal of the Hubble constant, one could calculate the exact moment the cosmos came into existence. Hubble initially estimated the constant at around 500 kilometers per second per megaparsec, which suggested that the universe was only about 2 billion years old.